All right, let's look at question 11. This was an interesting kind of exploratory question for you. The question was, we've got this function, which you've probably never seen before, sine of 2x over sine of 3x, and I wanted you to be able to predict in the graph for this function, when is there a vertical asymptote, when is there a hole, and when is there an x-intercept? So to be able to predict these things, you have to have a pretty solid theory about when do each of these types of things happen. So let's forget this. Let's make a simple example. When does a vertical asymptote happen? Well, if I have like 1 over x minus 1, you know that that's just a rational function that looks like this, only we have shifted it right by 1. So here would be the new y-axis, and then here would be my vertical asymptote at x equals 1. And it makes sense because when you plug in 1, you get a 0 in the denominator here. All right. So that's what creates a vertical asymptote. What if I had this, x minus 1 over x minus 1? What does that graph look like? Well, you'll notice that this simplifies to just the graph y equals 1. So if I was going to graph that, that looks like this kind of flat graph here, except for one thing. The domains of these two functions are different. The domain of y equals 1 is all real numbers. The domain of this function is all real numbers except for 1. So that creates a hole right at x equals 1, like this. So whenever I have, and like let's think about what happens when I plug in x equals 1, I get 0 over 0. So this is a good example of the type of situation where you're going to have a hole. All right, what about x-intercept? X-intercept would be like x minus 1 over 2. Here, when I plug in x equals 1, I'll get 0 over 2, or a y value of 0. So these three cases cover all of the possible things that could happen with a fraction where you have a 0 involved. Here we've got a number that's not 0 divided by 0. Here we've got 0 divided by 0. Here we've got 0 divided by a number that's not 0. And those are all the possible things that could happen. So now I know when it looks like this, it's vertical asymptote. When I look like this, it's hole. When I look like this, it's x-intercept. All right, based on that theory now, I want to think about the numerator and the denominator of my function to try and figure out when's the numerator going to be 0? When's the denominator going to be 0? So here's my function, sine 2x, sine 3x. In order to make my predictions, I need to know when is this numerator going to be 0? And is the denominator going to be 0 at the same x values? I don't know. Because I said I didn't want to graph it, I'm just going to have to think about it naturally. So I decided to make this little number line. So if you remember how to calculate period, the period of this upper one is going to be 2 pi divided by 2, or a period of pi. So that means I'm going to have sines that go like this. There's my sine function. I know it's got a period of pi, which means that it's hitting 0 at every single multiple of pi over 2. So here's my number line. Here I've written 0, pi, 2 pi, 3 pi. And because I know what the period of sine 2x is, I'm going to write little dots every single time this function gives me 0. So at pi over 2, at pi, at 3 pi over 2, at 4 pi over 2, at 5 pi over 2, and so on. So all the multiples of pi over 2. All right, same thing down here. Sine 3x, if I'm going to calculate the period of that, it's 2 pi over 3. And so if I draw my sine function here, this is, 2 pi over 3. So that means that this must be halfway is 2 pi over 6, which is the same thing as pi over 3. So I've got a 0 at pi over 3, and at 2 pi over 3, and at 3 pi over 3, and at 4 pi over 3, and so on. So if I superimpose that here on my chart, I've got sine 3x is 0 at 0 and pi over 3 and 2 pi over 3 and 3 pi over 3 and 4 pi over 3 and 5 pi over 3 and so on. All right, so just looking at this picture, let's look at what's going to happen with the numerator and the denominator at different x values. So it looks like whenever I have a multiple of pi, a whole integer multiple of pi, both of these functions take on a 0 value. And I know from before, that's exactly the situation where there's going to be a hole in my function. So I got holes there. All right, I know that at multiples of pi over 3, my denominator is going to take on a 0 value. So as long as that's not an entire multiple of pi, I know that I'll have a non-zero number in the numerator. So it's like I'll have some number that's not 0 divided by 0. That's exactly the case where there's a vertical asymptote. So all of these guys are vertical asymptotes. And then the last case is at the multiples of pi over 2. As you can see, at the multiples of pi over 2 that aren't also multiples of pi, we've got sine 2x is 0, but sine 3x is not 0. So my original fraction is going to be 0 over not 0. And that's the situation where there's an x-intercept. So that's why I wrote in the middle here, there are x-intercepts. So that's it. I've predicted the pattern completely. If you want to write this down kind of more mathematically, you can use this notation. I said that there are holes at every positive integer multiple of pi. So at x values that are the same as pi times k, where k is an integer. And a good way of writing k as an integer is like this. K, member of the set, and then this kind of weird looking z, that's the set of all integers. So this just means k must be an integer, and all the x values that satisfy this equation when k is an integer are going to count. All right, let's take a look at what the actual graph looks like so that we can be sure we like it. Sine 2x divided by sine 3x. And here you see I've got, well, what do I have here? So here at pi over 2, and at 3 pi over 2, and at 5 pi over 2, I've got my x-intercepts. It looks like these vertical asymptotes, they're not drawn in, but you can kind of see how they're spaced. And then where were my, what else was I looking for? Oh, holes. So Desmos doesn't actually show us the holes, but it looks like they're here at 0, and then pi, and then 2 pi, and 3 pi. If we wanted to, we could sort of look, I don't know if this is going to be too confusing, but let's look at the pieces separately. Right, so you see wherever the two graphs come together, here, and here, and here, that's where you get the holes. Whenever the green graph, which is sine 3x, has a 0, that's where you get the vertical asymptote. See how those line up? Here I've got a 0 for the green graph and a vertical asymptote. Wherever the blue graph has zeros, that's where I'm getting my zeros for the overall function. All right, that's it.